So next is binding these external references to it. So one way of doing it is you right click on this drawing and then click on bind. So now you have two options to it. You either can bind the object or you can insert the object. So when you use the insert object, then all the named objects will be merged into the drawing without any prefixes. So if any duplicate named objects are there, then AutoCAD use the named objects in the drawing. So in certain cases where we do not know whether there are any duplicate objects or there are what are the types of the objects that has been defined in the original XRef option, it is always safe to go for the bind option. So in bind, what we are doing is we are making the external reference as a permanent part of the drawing. That is, we are no more going with the term of an external reference, but rather it will get an integral part of the current drawing. So now when we click on this bind, now this drawing, you can see that it becomes an internal part, but now it has got converted into a block definition. So this drawing now gets converted back to a block, so that all the block options that you are going to have seen earlier can be applied here. So this is going to be useful. This binding is going to be useful in two cases. One thing is that once you have frozen all the designs of the subcomponents and then you're proceeding with the final assembly drawing, and then you just have to store it away or archive it in a location, then you can use that. You can take away all the references of the individual drawing and then make it as a single drawing. So in that case, this is useful. Or the other case is if you're integrating all the components of all the designers together and then proceeding on to next stage, and here on you do not want to differentiate between the different parts and you want to retain all those as a single part, single component in the current drawing, then you can use the external reference as a binded reference. So this is about the external reference binding. So with this, you can go on and construct the drawing that we have seen earlier. So here we have seen that this is the intended subassembly drawing with the different parts that we looked into. So you can go on and proceed with this, integrating all these components together. So when you're inserting as an overlay, and then you will see one more command here. So instead of right clicking here and then clicking on binding, we'll now use the command prompt of way, that is you go for an X bind. So now we'll get the window for external referencing object binding. So here what you can see is you can see all the conditions that you want to bind it to it. So it means that whether you want to insert what properties that you want to have and what needs to be deleted, so that the drawing by default is going to get inserted as a block. So that we can do here. So that by default this block will be an added reference, but then what type of information that do we want to bind to it? So suppose in layers, I just want to take the layer 0 here, and in line type, this line type, randomly selecting it and then clicking on binding. So what happens is only those properties will get binded to here. You can see that the wheel casing 0 and then the dimension cells all have got binded here. You can see that there is the difference of the line properties that you have here. So this is about the X bind and using selective dimensions binding. So alternatively, if you want to bind it as a whole, then click on the bind type and then take the drawing as a whole here. So after binding this, now you might come across a situation where you need to modify this original drawing content so so as to suit your current drawing. So in that case, if you see that when you click on the drawing or double click it, even after binding, it's the block element only. Okay, so even if you want to edit it out, if you click on go in the block editor command, then you can edit the individual components separately only inside the block editor command. That means this object is still stored as a block in your drawing, and whatever you're updating has to be done through the block editor command only. But instead, if you want to take into notes of separate elements, then what you can make use of is the explode command. Explode. So typically what you're doing by explode is you're breaking down this compound object or the block into its constituent elements. So this is, once you click on explode, the first requirement is the selection of the objects that you want to explode. Click on enter, and now you get the options of how to getting explode. So the first option is exploding all. So it means that it will set the color, the line type, line weight, layers all as a separate layer, and then assign the properties to it, so that each and every time it will get input is asked from you, and then you have to assign the separate color, layer type, all those things to it. So that is by the all option. Whereas going by the color, sets the color of the objects after we explode them. So this is layer, line type. So we'll look into this one by one. So if you click on explode directly, the whole elements got deleted. So in order to understand it, whether this is the property of the base object, let us quickly undo it. That is, we are retaining back into this original block definition. Now we'll edit this block in place and see how it is referred to. So in this object, you can see that if you click on this hole, that itself is defined as a proxy entity as an AutoCAD block. So it means that it's a block to block itself, and hence these blocks are not getting converted. So for this drawing, when you modify it using the explode command, you can see that all the proxy elements are removed from the original block references. So the same can get happen here with this explode object here. But now let us go by the all option. So what it asks is, it asks separately for the color. So we can go by the either the layer or by the block definition. And the new line type, that's also by block definition. Line weight as the block definition. So whatever we are using the existing block, let us try and reuse. So what is the new layer name of this exported objects? So let us use the object layer name, retain the same layer 0. And now you can see again the proxy elements of those blocks has been removed. So this is the option of an explode. So this explode can also be done to different block definitions also. That is, we are breaking down the constituent elements into this picture. So one more thing what you can observe here is, after creating the drawing and after creating the several named instances and so on and so forth, so there are several layers that are not utilized for, that have been taken away from the drawing. So in that case, if you want to remove such instances of the named object creations, then you can use the purge command to remove all those unused named object or references. So we can click in either the purge command through here, or so once you click on the purgeable items and select on this, so you can see that all the layers that are not utilized will get displayed. And again, all these ones, the dimension styles and all those things that are not being utilized, can be purged away from the existing drawing definition by clicking on this command. So by purging away all the items, okay, so only that is retained in here that has a direct reference to it, because once you click on the non-purgeable layers, so this is the defined layers that is called for in the current drawing that has a reference to the current drawing. So in that case, all the others, because basically in your drawing, we cannot see any difference, but in other sections, we can see the major difference, and thereby we have simplified the drawing views. So this is how the purge command can be used to remove any unreferenced objects. So this can also be taken from file, drawing utilities, and then purge. Also, this is we have an audit facility. So this is a diagnostic tool that is used for examining the current drawing and to check for any errors. So for every error, it's the AutoCAD detects. It recommends a corrective action. So we can click the fix any errors that are detected. So it runs to all the objects that is fine to it. So whatever objects that are present in this, including the header, tables, block definitions, all those things, AutoCAD runs through its own database and see whether it is requiring for any specific editing or not. So this is the function of the audit tool. And suppose if the drawing contains errors that the audit command itself cannot fix it, then we can use the recover command in the drawing utilities. So if the AutoCAD software determines that the drawing that we are opening is damaged or based or changed automatically, then it will show the prompt. So right now what we are saying is this drawing is currently being used. So would you like to open as a file, a read-only file? So suppose if it's a damaged one, so during opening itself, it will try and repair all the errors that are found in the drawing. So this is a quick fix on the drawing utilities that AutoCAD offers us. So this can also be seen in the Manage tab, where it's available in the Cleanup tab, where we can purge the items or remove or checks the integrity of the drawing using audit. So next is a great addition as apart from the AutoCAD interface. There is called as a design center. So this design center is something that you can use to organize the access to drawings, blocks, hatch, or any other drawing content. So it simply means that you can drag content from any source drawing to the current drawing. So it means that it is a quick reference of all your existing database, all the existing block references, all the existing drawings, so that you can quickly drag and drop to it. So this is like your own personal Jarvis, so that you can quickly invoke whatever you want to this drawing. The source drawings can be on the system that you work on, or on a network location, or a website, or your internal PLM software. So whatever it is, you can take into any drawing that you work on. Even if you have multiple drawings that are open, you can use this design center to streamline the drawing process by copying and pasting one content to other, so that you can take all the layer definitions, the layouts, or the text styles between those drawings. So we'll quickly see that now. So the design center can be invoked by two manners. In the tools menu in palette, you have the design center, or using the command control plus 2, control and 2. So alternatively, you can also go in this view tab, and in this palettes you can find the design center here. So also it is invoked by the command AD center, that is AutoCAD design center. So now this is the design center interface. So here you can see the tree structure, where we have the different folders that you work upon, and what are the current drawings that are already opened upon. So right now we have 3 drawings here, and the other existing drawings, and also you can open upon all the history that you have worked upon. And you can also use this option to search for any drawings with whatever keywords that you have defined, either in the file name, title, subject, or other modifiers that you have. Because if you could recollect, we had used several block definitions, attributes to define each and every block. So with that, all these individual metadata information, we can either look for drawings or blocks or layers or whatever customized text that you have inside your system or the locations. So also here you can quickly see in the design center that AutoCAD have by default. You can see all the categories of drawings that are available here, and within those drawings, suppose if we take this drawing as fasteners metrics, you can see the different categories of the info that is available. It is describes the blocks, the dimension styles, layers, and so on and so forth. Once you expand it and then click on blocks, then you can see all the blocks that are defined in those drawings. So you can see you have the hex nut on the top view, the side view, the screws, all those things it's there. And likewise in the open drawings, in this you can also see the drawings that we created, the first and third angle of projections. So whenever you want to take these into your drawings, then you can open up those drawings or the blocks that you've created and use it. So this is the major functionality of the design center. That is, you can use this design center to browse the drawing content such as the drawings or symbol libraries within our computer or a network drive or a web page. Also, we can view the definition tables for the named objects such as blocks and all those things and then retrieve, or we can update the drawing definition that is already there by editing it using the block editor command. And we can open the drawings in a new window. So we can copy the block here and then paste it in here, or rather we can directly move it around in here by pasting the clipboard point. So you can see that the object gets moved to the current drawing from an existing drawing. Also, all the predefined objects can also be taken here. So suppose if you want to take it, you can click on the insert block or double click it, and then now you get the block insertion command, and by this you can insert the block that is of reference to it. So this is the major implication or usage of the design center. So here we can, as seen, you can use the search option to go and look into search the metadata information rather quickly. So once having inserted the block into your definition, so now you can see that all the original properties of the block gets written. So here, based on the visibility that we have designed, we can select it out. And so here typically this block doesn't have any dynamic references, so but the drawing that we had created had it, so that you can use those customized drawings into your original drawing. Also, we can find out, we'll go to this design center once more, and within the existing catalog that is available, so here you can see that in the sample section, mechanical samples, you can see all those are already available in it. So certain customized blocks that are required for certain processes can also be pulled from an existing database. So it means that as an organization, you can retrieve all the existing components that were created for projects elsewhere and then reuse into your original drawing. As well as here in the dynamic block setting, you also have the dynamic blocks that we have seen earlier. So here you also have the roller bearings component and then all other components that are of interest to us. You also have the sheet sets tab within the sample folder in AutoCAD, where you have the different sheet sets that are defined in here. Suppose in the cover sheet blocks definition, if you go on, you can see that we have the title block definition here. So thereby you can use the title references, title as a block, and then you can customize it based on the data. So on double clicking it, you can go and edit the block content only to this drawing. So as we seen earlier, the block once inserted does not modify the original content. So based on the requirement, you can modify the application as required. So this sums up the usage of Design Center to utilize previously established blocks and references into your drawing and taking references between active drawings also. So next, one more variation what we have to this is the tool palettes. So tool palettes is kind of similar to the Design Center, except that is we can custom create the palette that we want to have, just like a painter's palette. We can focus only those components that are interest of to us and then store it in a separate one. So it simply means that we can hide those extra toolbars and extra menu bars, the panels, all those things, and only retain all those are of required to us. So you can see that in this tool palette by default you have the annotation tab, wherein right from the Design Center whatever annotations you have, the same thing has been called out here. Then you have separate sample for architectural, and then mechanical we have the valves, the metric samples and impedance samples, like waste, so on and so forth. Also we have the tables that can be inserted, and then example for command tools, leaders, specific definition of those leaders wherein we can use, and then the draw commands. So this means that this tool tab palettes or tabbed areas like this within the tool palette window. So these are all custom tools. So that is, it means that if I want to use this R, then I can drag and drop it onto here. So when dragging and dropping it, it will invoke the that command. So likewise, suppose if we want to take a shoulder screw, so I'm then dragging and dropping into it so as to insert the block model to it. So this tool palette we can use to configure several geometric objects that we have seen, like the lines, circles, arc, polylines, and then we can also create dimensions, blocks, hatches, solid fill, gradient fills, raster images or external references. So it means that you are using a quick access panel wherein you are keeping reference all the frequently used thing. For example, you can create any custom object of, say, with a fixed line type and a line reference, and then store it in here. So whenever you're using it, the same thing can be applied. So what you can do here is, on the tool palette, so on right clicking it, it has merged here, but right clicking on this tabs, you can see that you have the customization to move the palette across. So let us undock it to have more clear, and let us close it out, external reference. Yeah. So on properties, clicking on this gear icon on the tool palette, here you can see what are the different properties that are allowing for. So here you have the customize option for the palette or the command, and also we can list out all the palettes that are predefined. So currently all the palettes have been predefined. So we have the annotation and design palette, okay, and then we have the parametric design, architectural, civil, structural, manufacturing, and so on and so forth. Suppose if we click on mechanical, only those that are relevant to mechanical palettes get displayed. So for example, if you go for the visual styles, those that are pertaining to the visual styles are listed. And so if you go for the all palettes, all the palettes that are applicable are shown in here. So this is the overall general settings of this. Alternatively, you can also go for the customized palette. So here you can see what are the different palettes that are available. Suppose in this draw palette, so this draw palette can be included in any one of these palette groups. So means that suppose if I include a new group here, okay, let me just take it in the, okay, so a new group has been inserted here, and then now let us, we can add the draw to this new group, tables to this new group, hatches and fillers to this new group, and so on. So now when we go and take the annotation and design and then select this new group, so now we can see that we have made a custom palette wherein we have only the draw, tables, and then hatchet fills. So by this we can quickly use this. So we do not need to take the B hatch option to do all this hatching. So we can quickly take this hatch pattern and then apply to this to here. So you can now see the hatch command has been quickly executed with this command in place and then taking it in direct reference. So you do not need to have to call for this command. You do not have to edit these definitions and so on and so forth. So this is the application of a quick reference of the panel. So alternatively, you can modify these commands. Suppose for this that we have inserted, right clicking it and then specifying on the properties by which we can optimize the specific tool properties pertaining to that command. So what we have taken was a hatch command. So we'll get the properties that are pertaining to the hatch. So it can either be a hatch or a gradient, and what are the types it is, what is the pattern name, scaling of it, and then colors, the line type, line style, all those things has been described in it. So likewise, suppose if we want to go for an existing option, suppose if in the rectangle command, then again you can specify what is the colors that you want to go out to it. So by this we can customize the frequently used options that we have using within the tool palette. So also, instead of creating a new group, we can also create a new palette here, and now we can add components to it by customizing it, and alternatively you can also create your own custom course to describe that, say this is an user palette or so on and so forth. So by this we can insert elements to it. Suppose if we want to take this element, so now by dragging and dropping this block that we have already created onto this user palette, so now we can see that this has been inserted, and this palette will get carried across all the drawings that you have. So this is similar to the design center, except to the point that this is a quick reference, quick action palette that you have. So by this you can take across different components that you work on. So in this our custom panel, suppose if you want to include a rectangle command, then you can go here, or suppose if you want to have the insert block command, then you can right click on it, copy the command, and then paste it in your new palette as required. So but thereby you can create a custom made one. You need not have to shuffle between the different tabs or between the commands. You can go for a quick drag and drop of the commands that you frequently go for. So this is the tool palettes, a powerful functionality, and the design center that we have looked so far. So let's quickly summarize the learnings that we have done today. So we have seen into several file management techniques. What is the requirement of a file to be managed effectively, and how are the various strategies that goes on to name and structure your folders, and then what are the different file nomenclature and naming conventions that you can adopt from BS 119 standards, and we also have seen what is the importance of a version control document in your product, and the ways wherein you can try out existing version control tools that are available as in SVN or Git. And I recommend you guys to download them, have a tutorial on it to understand how the version control management works in, so that you have a very good idea of it, and then try to apply it into your day-to-day drawings, and definitely you'll see the usage of it and will get adapted to it. So next we have seen the external references, usage of overlay or attachment. We've seen how the nested references is going to look like, and the differences between your overlay and attachment and when to use which. And then we also looked into Xbind option to bind the drawing effectively into your existing drawing so that you retain them as a part of the drawing itself. And also we looked into the explode option to break down the component into its individual object so that you can work upon. And then we saw a lot of design center methodologies where you can take in the title block references or mechanical components, and also you can use the blocks that you've already created in previous drawings to replicate in other drawings, and then you can also move around the blocks or the different properties that we see in the layers or the line types across drawings based on the design center. And also we looked into the effective usage of the tool palettes, wherein you can use it to customize your own palette based on the current drawing that you work on or the project that you work on. And you can also bring in different elements that across the other drawings that we've seen in design center into this, so as to quickly deliver the content that you intend to do. So these are the various collaborative techniques that are available in AutoCAD that you can use to enhance your productivity and also collaborate effectively amongst your team so as to enhance the productivity of the entire team.